The central limit theorem. The central limit theorem is very important for the study of inferential statistics in that it relates the population parameters to the sample statistics. And what happens when you take a simple random sample? You will take a sample of size n, where n is greater than or equal to 30, and the size of your sample, n, over the size of the population will be less than 5%, hopefully. And if that's true, that means your sample is very small compared to the size of the population. If these two conditions are met with your simple random sample, okay, then we can say three things. In other words, the central limit theorem applies, and it says three basic things. Regardless of the distribution of the population, the distribution of all possible sample means, called the sampling distribution, will be approximately normally distributed. That is, if you took millions and millions and millions of samples of size n, okay, and simple random samples, and you took their means of every one, then those means would be normally distributed regardless of how the population itself is distributed. The population could be uniformly distributed, skewed one way or the other, or any distribution at all. Okay, the mean of all possible sample means equals the mean of the population, and we write it like this: mu of all the sample means will equal the mean of the population. And the third thing we can say about this sampling distribution, okay, is what is the size of the standard deviation? The size of the standard deviation of that sampling mean, which is normal, a normal distribution, will be the standard deviation of the population divided by the square root of the number in your sample. Okay, having said all this, we're going to solve a problem in part 2. So you can stop the movie right about here if you want and read this problem. This is the one you'll see in Central Limit Theorem Part 2. We'll solve this one, but see if you can work on it and get something going with it.